Hey kids, Flexing Teacher Weber here with part 2 of dividing integers. In the first video, we established the rules for dividing integers by showing what division means and using models and related multiplication to prove that these rules actually apply. I sort of think it's important to make sure you know why things are the way they are. I could just tell you that a positive divided by a negative is a negative, but I think it's important to show you why that is, right? You shouldn't just believe it because your teacher tells you so. So we established that a positive divided by a positive is a positive. A negative divided by a positive is a negative. A positive divided by a negative is a negative. A negative divided by a negative is a positive. And so we established that the rules for integer division are the same as the rules for integer multiplication. If the signs are the same, it's positive, like in these two right here. Same signs, it's positive, like a positive and a positive, or a negative and a negative. Oh, having trouble writing right now. And if the signs are different, like these two, then it's a negative answer. So different signs. Like, I'm having some trouble. My stylus is being a bit funny. Different signs. Okay, let's do a little application of that right now. So, of course, the simplest application is just doing some actual fact questions, right? Finding the quotient. So, negative 18 divided by 2 would be negative 9 because it's a negative divided by a positive. And 21 divided by negative 3 would be negative 7 because it's a positive divided by negative. And negative 72 divided by negative 8 would be positive 9 because a negative divided by a negative is a positive, and negative 63 divided by negative 7 would be positive 9 because a negative divided by a negative is a positive. All right. What about situations where you have larger numbers? Now, I really like getting the kids thinking about different ways you can pull apart numbers. So I'm a big fan of algorithms, but I also like getting the kids to be creative with their numbers. I think it's really important that they can manipulate numbers around. So let's say you have a question like negative 128 divided by positive 4. Really want them to think about ways they could break numbers apart to divide this in parts. So you could do something like this. You could do negative 120 divided by 4 plus negative 8 divided by 4. And that's equal to 12 divided by 4 is negative 30 plus negative 2. I really think, even though some kids can maybe look at that question and do it, I think it's important to be able to pull numbers apart. And so that ends up equaling negative 32. The more you can do that, the better number sense you'll have. And even better if you can realize that there's more than one way to do this, right? You could also do, negative 100 divided by 4 plus negative 8 divided by 4. And you'd get negative 25. That should be, of course, you have to do it right? So negative 100 divided by 4 and negative 28 divided by 4. Because these have to add to negative 128. And when you divide this in parts, you get negative 25 and you get negative 7. And again, you come up with that same answer of negative 32. I think it's important to be able to play around with numbers. It really develops number sense when you can do that. So same thing here, negative 366 divided by 6, or negative 6. Well, my first thought is you could do negative 300 divided by negative 6 plus negative 66 divided by negative 6. This would be 30 divided by 6 is 5, so 50. Plus 66 divided by 6 is 11. The signs are the same, so it's positive 61. You could also do negative 360 plus negative 6. The same thing down here. 525 divided by negative 5. Most people would do, negative, 500 plus 25. But you can be so creative with this. Like you could do 200 divided by negative 5 plus 200 divided by negative 5 plus 100 divided by negative 5 plus 25 divided by negative 5. I don't know why you do that, but the point is, thinking like this develops your number sense. So negative 200 divided by 5 is negative 40 plus negative 40, right? You're doing that twice. Okay. And 100 divided by negative 5 is negative 20. And 25 divided by negative 5 is negative 5. You could add all those up. 40 plus 20 is 100 plus 5. That equals negative 105. I mean, it would have been just way simpler to do 500 divided by negative 5 and 25 divided by negative 5. But just want to show that you can be creative with your numbers, and that really develops your number sense. So I'd like to have the kids do that sort of thing. Because that way you might recognize things like number 8. If you don't recognize in number 8 that negative 459 could be negative 450 divided by 9, and to do that you have to recognize that 45 is divisible by 9, and that only comes from developing your number sense. Kids that don't have that number sense can't do things like that because they just haven't played around with the numbers. You want the numbers to sort of bounce around easily in your head, and that's one of the ways you can develop that. So 45 divided by 9 is 5, negative 50, plus negative 9 divided by 9 is negative 1, and that equals negative 51. Okay, so all these ways are ways we can divide larger numbers, and then remembering our sign rules. The last thing I want to do involves sort of an application of division, and that's finding the average or the mean. Now, finding the average or the mean is like a way of finding the middle of a set of data, or the central tendency. So a common question where you might see this with integers is temperature. Over a period of 6 days, the temperature in Winnipeg was negative 5, negative 6, negative 9, negative 7, negative 5, and negative 4. All these temperatures were in degrees Celsius. What was the average temperature over those days? And another way we say average, we also say that's the mean. Okay, so the way you find the average is you have to add up all your data. So we're going to add up all those temperatures. Okay, and then we're going to divide by the number of pieces of data we have. We're going to divide by 6. I often see kids do this, and that's wrong. That means we're only dividing the negative 4 by 6. We want to divide that total by 6. So we have to make a fraction. And then what we might do to add these up is we'll add compatible pairs. So I see negative 5 plus negative 5 is negative 10. Negative 6 plus negative 4 is negative 10. That's negative 20. Negative 9 and negative 7 is negative 16. So negative 20 and negative 16 will be negative 36. And we take that total and we divide that by 6. And then that will get us our mean or our average. So negative 36 divided by 6 is negative 6 degrees Celsius. And that's about the middle temperature, the measure of central tendency of those 6 days. And that gives us a good idea of what the temperature was like over that period. So that's an application of division of integers. So with division of integers, you have to be able to remember the sign rules. You have to be able to do a little problem solving. And you should be able to divide some bigger numbers like these and come up with some mental strategies to divide them. So that's all for dividing integers. That gives you everything you need to work on the assignment that I gave today. I hope that helps. That's all for now. Flexing Teacher Weber, out.